Alright guys, we are back at it. We have our commands that we saved from the command line module. Next is textfu. And I kind of want to, as I keep going, keep using this stuff, right? So ls with t flag to sort the modification time, that's a good one. So maybe each time I do something, I'm going to try to implement one of these. But let's start this out. So standard out. By now we've become familiar with many commands and their output, and that brings us to our next subject, I/O streams. Let's run the following command and we'll discuss how it works. Alright, let's try this out. Back here. Let's give this a try here. Alright. Let's do cat peanuts.txt. Alright, so I think this goes back to what we were doing last time, which is basically, how do you move this? There we go. Which is the redirection, right? So, let's see if we can implement something new here. Let's do an ls lat. And I feel like that peanuts one should come up. Don't see it here. Oh, there it is. Yeah, it's the first one. Let's do a reverse. Can we do a reverse on this? ls help t sort by time new is first. Can we sort by time in reverse? Reverse. Let's do that. ls lat r. And there we go. All right, cool. So, what just happened? We'll check the directory where you ran that command in the I/O, and behold, you should see the file called peanuts.txt. Look inside the file, and you should see the text "Hello World." Lots of things just happen in one command. Let's break it down. First, let's break down the first part. Echo "Hello World." We know this prints out "Hello World" to the screen, but how? Processes use I/O streams to receive input and return output. By default, the echo command takes the input, right here, the standard input, from the keyboard and returns the output, standard output, to the screen. So that's why when you type echo "Hello World" in your shell, you get "Hello World" on the screen. However, I/O redirection allows us to change this default behavior, giving us greater file flexibility. Okay, so let me get this straight. So when you type, so basically you got this program called echo, and when you put something in its standard input called "Hello World," that's not going to work. So this is the standard input, "Hello World," and then it outputs "Hello World." Right? So now we want to redirect that output. Let's proceed to the next part. This arrow is a redirection operator that allows us to change where standard output goes. It allows us to send the output of echo "Hello World" to a file instead of the screen. If the file does not already exist, it will create it for us. However, if it does exist, it will overwrite it. You can add a shell flag to prevent this. Let's try to do that. Let's do what's the shell flag? Is the shell flag like an I? Interactive? Nope, that didn't do it. Let's see if it's in here. So we got, where was the interactive part here to show the contents of the file, less command, history, previous command, control G. This looks like it would do that, but how do you get the, alright, let's see. Linux redirection. What would it be, like interactive? I'd like to prevent this depending on what shell you are using. Linux redirection overwrite. I don't know. Let's see what we get. Write to file, but overwrite if it exists. Best way to, let's do protect. Overwrite. Prevent overwriting a file with redirection. Bash. Is there an option to configure the shell not to overwrite? Yeah, that's what we're looking for. Yes, there is the no clobber option. Prevent output redirection using this and that from overwriting existing. So set no clobber. Foobar cannot overwrite existing. Oh, that's weird. Okay, so set no clobber. And let's do this again here. Overwrite existing, right? So now how do we shut this off? That's the question. So set help. What is O? Option. Option no clobber. Are we allowed to reverse this? Let's see. How do we clobber it? How do you turn that back off? Yeah, I don't know. Maybe just run it again? That didn't do it. True. Okay. Let's see. Turn off no clobber. When setting no clobber, overwriting the content of an existing file redirection operator will not be possible. You might have typed to redirect the output of a certain command to an existing file, while instead you intend to use whatever. Okay. If you are determined to overwrite the file, you can use this method. Oh, okay. Let's try that out. Boom. Okay. Let's actually do this. So cat peanuts. Yeah, that's nice. Okay, I kind of like that. To unset the no clobber. Okay. I don't know if I want to keep the clobber on. So let's do this. Oh, no clobber. Oh, that's cool. That's good to know. No clobber. Alright, pretty cool. Pretty cool stuff here. Can use this later. Alright, and that's basically how standard out redirection works. Well, let's say I don't want to overwrite. Luckily, there is a redirection operator for that as well. Right, this appends it. This will append hello world to the end of peanuts. So let's do this. I wonder if this still works, actually. Yep, cool. Let's append this. Cat peanuts. Boom. All right. If the file doesn't already exist, it will create it. The redirector, standard in. In our previous lesson, we learned that we have different standard out streams we can use, such as a file or the screen. Well, there are also different inputs we can use as well. We know that we have standard in from devices like the keyboard, but we can use files output from other processes and the terminal as well. Let's see an example. All right, so looks like we're concatenating, we're taking what's in peanuts, concatenating it, and putting it into banana. All right, let's try this out. I don't like that it's in a weird order, but let's try this out. cat banana. Yep, looks like it. Okay, so this first step happened, and then this. Just like we had for standard redirection, I wonder if like you could do a parentheses on this. Right? Let's try this out. No way. Cat banana. Oh, that's awesome. Okay. Wait, let's see if this works actually. Let's do banana. Banana. Append it. Input file is output file. Okay, I got you. Let's do banana 2. So cat banana2.txt. Alright, that's cool. I like that we can use parentheses like this. This way, it's kind of clear what's happening first. Normally in the cat command, you send a file to it, and that file becomes the standard in. In this case, we redirected peanuts to be our standard in. Then the output of the cat peanuts, which would be hello world, gets redirected to another file. Alright, cool. Oh, you know what we missed was kind of the quizzes here. Let's try a couple commands. LSL, that puts it into the output, echo hello world to RM. What does that do? That's an interesting one. Wait a minute. That's not good. Alright, let's do this. Let's see if we can play around like this a little bit. It's a little bit annoying, but alright, so I think this will just give us the output of LSL. Let's do a LSL AT cat my output. Nice. Alright. Or log. Alright. Let's do echo hey there to RM. That just deletes it, huh? It's kind of weird because this isn't like a file, so the fact that it's removing it is kind of weird. Some file text. I guess that's just gonna create it. Some file.txt cat some file. Yeah, so it's probably the same as touch. All right, what redirector do you use to append output? Well, we know that one. Try a couple of commands. So we just did this one. ls, what would ls do? Peanuts. Whoa. So we got ls takes in peanuts.txt and then throws it into banana. Let's do banana ls.txt. Cat banana ls.txt. That's weird. Alright. What does ls peanuts.txt do? So that doesn't do anything. It just, like, it doesn't matter what the standard input is, it just runs it anyway. I feel like it'll be the same for pwd. Peanuts.txt. Yeah, alright. That's interesting. What redirector do you use to redirect standard in? We're using that. Alright. You know what? Let's not forget to use some of this stuff. So for the next one, let's actually, what do we have here? Less banana 2.txt. So it doesn't look like we got anything going on. If I want to search for world, that doesn't work. You gotta use case sensitive, I guess. Let me see here. Yep. Boom. Alright, cool. Alright, standard error. Let's try something a little different now. Let's try to list the contents of a directory that doesn't exist on our system and redirect the output to the peanuts file. Okay. Well, let's first get the, let's first get that. So we get cannot access. So if we put that into peanuts.txt, huh. Okay, so how do we get rid of the error? Probably this right here. Now you're probably thinking, shouldn't that message have been sent to, yeah, I am thinking that. Okay. It just created the file. It didn't, oh, because this is standard output. So it didn't have anything to output, and so it's empty. So we didn't actually add standard error. All right. Now you're probably thinking, shouldn't that message have been sent to the file? There's actually another IO stream in play here called standard error. By default, let me make sure you guys get the sound. By default, standard error sends its output to the screen as well. It's a completely different stream than standard out. So you'll need to redirect its output a different way. Okay. Unfortunately, the redirector is not as nice as using one of these, but it's pretty close. We will have to use file descriptors. File descriptors. A file descriptor is a non-negative number. All right, let's put this in here. Bash concepts. File descriptors. Okay. File descriptor is a non-negative number that is used to access a file or stream. We will go in depth about this later, but for now, know that the file descriptor for standard in, standard out. Okay, so let's do that. File descriptor, non-negative number is used to access a file or stream. Non-negative number, and then we got, let's do this. We got one is standard in. Well, actually that's 0, sorry. Then we got one is standard out, and 2 is standard error. What is going on here? All right, whatever. Okay, so now if we want to redirect our standard error to the file, we can do this. ls fake directory to peanut. Oh, so then we could just do this, and it'll show us the standard error. Okay, so let's try to put it into peanuts.txt. Cat peanuts, boom. All right, cool. So wait a minute. So if we do ls, 2 should show us, error unexpected token new line. LSL 2. That's weird. LSL 1. Not sure. Maybe we need a file. Peanuts.txt. Cat peanuts.txt. Boom. All right. So what if we try to look for an error here? It doesn't have that. So I guess, is it like also the standard out? That's kind of the question here. We will have by default standard sends its output to the screen as well. It's a completely different stream. Kind of confusing here, but all right. you should see just a standard error message. Now, what if I wanted to see both the standard error and the standard out in the peanuts.txt file? That's a good question. All right. So let's do this. ls peanuts and then 2 and 1 cat peanuts. All right, let's copy this in. Cat peanuts. All right, so that's kind of weird because, all right, so it's taking the output, it's putting it into here, and then I guess there is still some kind of an error, right? So like, okay, this sends the results of ls fake directory to the peanuts.txt file, and then it redirects standard error to the standard out via 2 and 1. The order of operations here matters. Sends standard error to whatever standard out is pointing to. In this case, standard out is pointing to a file. So this also sends standard error to a file. So if you open up the peanuts file, you should see both standard error and standard out in our case in the above command. Okay, I'm a little confused about this. Shorter way to redirect both. Okay, I like that. Now, if I don't want any of that cruft and want to get rid of standard error messages completely, okay. Let's try to understand this real quick, right? So, if I do this, let's actually keep it like this. If I do this, now if I do this, I guess it really needs to go somewhere. Like, cat peanuts. Whoa, see what just happened there, right? So it ran this, okay, it gave us the standard out. If you want to redirect both standard out and error. Okay, so how do I not redirect standard out? Like, how do I just have standard error? That's what I'm trying to understand here, right? Because if I do this, that'll return nothing here, and it'll go into the file. So cat peanuts, right? And what it did was it added a new line, and this is probably why we got that, right? So if I try to do like a let's do yeah, so it's expecting new line. So what if we just do like ls can we do like a head 1? Head n1. Yeah, let's try that. So boom, let's do a 1, boom. Nope, it does not do that. Okay, I don't even know what I'm doing at this point. But okay, this is good to know because it's putting this stuff in there. I feel like this is going to be a little, I have to get back to this. What is the following command doing? So lsfake, it's appending it to a non-existent file, and then it's returning both standard error and standard output. So we should get nothing back, right? Yeah, okay. Standard error redirector. Okay, gonna put like a star on that one. Get back to that. Pipe and T. Let's get into some plumbing now. Not really, but kinda. Let's try a command. LSLA etc. Alright, we know this one. LSLA is going to give us all the long format list of what's in, etc. That's a lot of stuff. Okay. You should see a very long list of items. Yep. It's a little hard to read, actually. Instead of redirecting this output to a file, wouldn't it be nice if we could just see the output in another command like less? Well, we can. Okay, that's cool. Alright. LSLA etc less, pipe it, and now we could go up and down. We can search for Python and still go up and down, but yeah, that's cool. MOT. So how come? Oh, there it is. All right, quit that real quick. The pipe operator, represented by a vertical bar, allows us to get standard out of a command and make that standard into another process. Got it. Okay. In this case, so it's kind of like doing less, and then you do like LSLA etc. Okay, so it's not letting us do parentheses. Nope, no good. We took the standard out of LSLA and then piped it to the less command. So what if we do like a LA etc standard out? Oh, it's saying there's no file there. Well, now, no, that's not good. Now there is a file there. So cat less. Okay, got it. The pipe command is extremely useful, and we will continue to use it for all eternity. Awesome. Well, what if I wanted to write the output of my command to two different streams? That's possible with the T command. Two different streams. You should see the output of ls on your stream, and if you open up the peanuts file, you should. Oh, cool. All right, ls t peanuts.txt cat peanuts. Very nice. I wonder why it adds kind of new lines here when I do it like this. All right, I like that one. So let's keep that. Let's keep this. Useful commands. Let's do I don't know if I should like have that. Yeah, let's do a new one here. Let's do a new one. Add that, and we'll call it textfu commands. One. Let's say ls, or let's say pipe and T. T allows us to save to a file as well as output to screen. Cool. All right. Let's try the following lst. So it's probably going to put it in both files, and it's going to show us what's up. So now if I do banana.txt, cat peanuts.txt, yeah, makes sense. What key represents the pipe? Shift backslash. All right, we're getting there. Environment. Run the following command. Echo home. Right. Okay. You should see the path of your home directory. Mine looks like home. So we just got environment variables here. What about this command? Echo user. You should see your username. Where is this information coming from? It's coming from your environment variables. Boom. Got a lot of stuff here. All right. Okay, I like it. I like this. All right. This outputs a whole lot of information about the environment variables you currently have set. These environments variables contain useful information. Right, where's the path one? We got a path here. I feel like I should just be able to path. Let's do env pipe to less, and then let's look for path. Oh, cool. All right, very nice. Let's look for PWD. There we go. Let's look for user. There we go. All right. One particular important variable is the path variable. You can access these variables by sticking the $ in front of the variable. Echo path. Yeah. This returns a list of paths separated by a colon that your system searches when it runs a command. Let's say you manually download and install a package from the internet and put it into a non-standard directory and want to run that command. You type the $cool command and the prompt says command not found. Well, that's silly. You were looking at the binary in a folder and know it exists. What is happening is that path variable doesn't check that directory for this binary, so it's throwing an error. Right, okay, so like when you type in a command, let's see, where is ls? It's got it in here, and that's in the path, I guess. What's happening is the path variable doesn't check the directory. Let's say you had a ton of binaries you wanted to run out of the directory. You just modify the path to include the directory, right? Okay. Very cool. Alrighty. Should I put? Let me put that in there because I feel like that's an important one. Env command tells you environment variables. Can also echo $ variable name. All right. Cut. All right, let's save this for the next one because I feel like it goes together.